In this problem, we're given the half-lives of two different nuclides, technetium-99 and thallium-201. And we're asked to calculate the percent of radioactivity left for each of these two isotopes after 2 days. I see this as a two-part problem. For each of these isotopes, we can calculate K from T1/2, and then once we have K, we can use the integrated first-order rate law to calculate the fraction abundance left. The half-life is ln of 2 divided by K, so K can be calculated as ln of 2 over T1/2. For technetium-99, it's ln of 2 divided by 6 hours, resulting in 0.1155. Units are hours minus 1. Now we apply the integrated first-order rate law. It tells us that ln of AT to A0 is equal to minus K times T. Now note this AT to A0 is the fraction that's left after some amount of time. Let's put in our numbers. We're carrying extra sig figs, so we have negative 0.1155. The units are hours minus 1, so hours goes in the denominator, and we're going to multiply that by 48 hours. This gives us the value of minus 5.545. Okay, so let's remind ourselves, this is the natural log of AT to A0. What we want is the value of AT to A0 itself. So to get that value, we raise e to this power. And the numerical value we get is 0.003906. And that's exactly what we've done, so we get our final result of 0.4%. Now there is an alternate pathway for this part of the problem because we actually have an integral number of half-lives in this problem. We can also calculate the amount remaining from A of t is equal to 1/2 raised to the n times A0. So we can write A of t to A0 is equal to 1/2 to the 8th power. And if we put this into our calculator, we see we get the same numerical result of 0.003906, or the same 0.4%. Now let's look at the second part of the problem. We want to do the same type thing for thallium-201. A quick calculation tells us how many half-lives have elapsed for thallium-201, and we can do the same calculation. A of t to A0 is going to equal 1/2 raised to the number of half-lives, and we can get our fraction left. The numerical result is 0.63398. And now using 2 sig figs, converting to percent by multiplying by 100%, this comes out to about 63%. A quick sanity check, 63%, not quite half of it gone, is a reasonable expectation considering that there hasn't been an entire half-life that has elapsed.